Okay, so we're gonna start with number 1 here. So in this case, we're doing f of g of x. So in this case, we're putting g into f, but there's 2 places that has to go in. So it's 4 and then parentheses, this 3x minus 5, that has to be raised to the 2nd power, plus 2 times 3x minus 5. So taking a minute here with this, understanding what's going on, we're putting that g into both places the x shows up. So now I need to actually FOIL this part. And remember, we don't want to distribute that power in. We have to actually write that twice. Bless you. So I have to do this before I'm going to distribute that 4, and I'm just going to write over here because I don't think you guys have questions on those. I don't know what's going on here.
It's because you have the underline.
What is it doing? It's like trying to search that or something. Okay. So this, when I FOIL this, and this is 9x squared minus 15x, it's still doing it. Oh, the underline little thing. Okay, sorry, thank you. I thought I had turned it off there, but apparently not. I sound like an old lady not knowing how to run my computer here. So that has to be combined here. I still have this thing to do too. I'm going to try and combine some like terms here. So when I FOIL 3x minus 5, this is what I should get. Now I have to distribute this 4 in and this 2 in. And then I just have like terms to combine. So the 36x squared doesn't have anything to go with. But these 2, so that's going to be a negative 114x, I believe, plus 90. Does that sound right? Okay. Then in number 4, they want you to do f of g of negative 2. So if you got 1 wrong, you probably are going to get number 4 wrong as well, because they want you to put negative 2 into that, or you can do it another way. So I could do g of negative 2. I think this is a little bit easier, but it's up to you guys. So I'm going to do that first. So I do 3 times negative 2 is negative 6 minus 5. So essentially what I'm doing is I figured out what g of negative 2 is, and that's negative 11. So now I have to do f of negative 11. So now I have to put negative 11 into the f here. So 4 and then negative 11 squared plus 2 times negative 11. Oh, geez. I should switch off of this, but anyway, and that's not working. But now, so this is 4 times 121 minus 22, and then that's how we ended up with 462. Or you could have put negative 2 into this one. Either way, it gives you the same outcome. I will not give you one that's that complicated on the test. That was pretty, like, crazy, like, complicated. All right?
You should put this sticker I sent. Oh, I don't know. Oh my God, that's you before. You ever before? Look at the work.
I apologize.
Oh my God.
Wish that I the worst.
I'm gonna flip off.
I think it's democracy of class. What? Let's do it. Do the dance. Anybody else? Anybody else? Do it. Let's go and show them the dance.
Okay. So let's go to number 6 then. Here.
While we're at it, can we go over 8?
Yeah.
While we're at it, can we just like take a break?
Oh
All
my
right.
gosh, guys.
Because that's going to be really helpful right now. Okay.
I'm struggling right now.
I'm
Next
really
exam.
struggling with this right now.
Wait, what? Do we have a break during the exam?
Let's go for a long.
Yeah.
Okay, so,
Let's chill all our little kids.
alright, okay guys, for finding the inverse functions, what we need to do here is we need to switch the x and y's. So technically this is like y equals 2x minus 3 over 4. So I have to flip where x and y are. So this becomes x equals 2y minus 3 all over 4. So what I need to do now is solve for y. So I'm going to take that and I'm going to try to get the y alone. So I'm going to undo the 4. And this is going to go away here. So I'll have 4x equals 2y minus 3. Should be equals. Now I'm trying to get y alone, so now I'm going to move the 3 back over. Oops, I lost the 3. And then to get y alone, we're going to divide by 2. So our inverse is just the complete mathematical opposite. Now number 8 I am not going to do right now because that's the only example like number 8, but I'm going to show you guys how to do that with number 6. Question?
No.
So if it asks me to verify something's an inverse, so what I'm going to do is show you guys how these two are inverses of each other. So again, I don't want to do number 8 because that's the only example like that. So let me show you how those two are inverses. So if it says to verify something's an inverse, what that means we have to do is I put the other function into the other one and it should equal x. So if I have my two functions here, so we'll use my, my h of x here. So we'll use number 6 to help us. So what we have to do is we have to put h inverse into the original h. So where you guys see x, I'm going to substitute this in place of that x. Now this one's a little bit complicated because of the fractions, but it doesn't hurt for us to try this one. So 2 times 4x plus 3 all over 2 minus 3 over 4. So I put that other function into it. So that's the same thing you guys would do on number 8. You take the one function and put it inside of the other. What happens now is I'm going to simplify this, and I want it to equal x to show that it's the inverse. So what happens first here? How can I simplify this? What's going to happen? Yep.
The, like, 4x plus 3 divided by 2, like the 2's cancel.
The 2's will cancel, yep. So get rid of those. So I'm left with 4x plus 3 minus 3 over 4. What happens next? 3's cancel. I'm left with 4x over 4. What happens?
The 4's cancel.
4's cancel. This is almost like, kind of like one of those so obvious that you're like, really that's all I'm doing? Yeah, you're putting the one equation into the other. The same thing should happen in number 8. And if it says to verify their inverses, they're not going to be not inverses. So like, it's not going to be like a trick question with that. Same thing for number 9. I wanted to show you guys another example of that just so that we're not, I want you guys to be able to practice in the review as well and not just me tell you what to do in all of these cases. Let's start kind of simple, I guess, with this. So like if I have x.
Wait, don't remember 8 being 4x plus 2
Okay, so what I said though, you have to listen here. I said that, I said verify their inverses. I was showing you one like number 8. I was using 6 to show you number 8. So you have to do the same thing in number 8 as I just did in number 6. So you're putting the one equation into the other. So you have to take this and put it in there. Otherwise, you guys, we have notes on this. This isn't the only time we've done this. So It's not, you should be, you're verifying its inverse. You're not finding an inverse, you're verifying that it is the inverse. So guys, real quick here, what I was gonna do with this doing the inverse on a graph, I was just gonna kind of do a graph here for us. To kind of show you guys what we need to do. So if this is my graph, what we do to find the inverse is I take the point, so this is -2, 3. I'm going to take all the points here. -1, 0, 1, 1, and then 2, -2. If I'm finding the inverse, I'm switching the x and y's. So I'm just flipping where they are. So my inverse of this would be 3, -2. You just flip it. 0, -1. This one doesn't flip, it's 1, 1. And then -2, 2. And some graphs look like that's the inverse, that makes sense. Other ones you'll be like, I don't know how that worked out that way, but it's the way it is. You flip those two. So there's the 1 here, same spot there, and then -2, 2. So this one, kind of a little bit wonky here. So that's the inverse. You're flipping where the x and y's are, okay? So same thing needs to be done at number 9. So these problems that are kind of singletons, I'm trying to do an example like it so that you guys can still go back and try and figure that out and like understand it and get practice on it. All right, we did number 6, right? Yeah. Yeah, that was an inverse one. All right, I'm gonna flip to number 11. All right, so I'll guarantee a problem similar to this will be on there. The e of 2x. First of all, this is something we're gonna end up factoring. If it's helpful to use the u substitution, you can. I don't really love that with this one, so what I like to do is move it, make it all equal 0. So I'm gonna move this all over to the other side. And I think it makes it look a little bit easier then. So I'm moving these both over. So this would be e to the 2x minus 3e to the x plus 28. Again, I think this looks a lot like this problem. So essentially this is kind of like that u substitution idea, the chunking idea, is that I know to factor this, e to the 2x, I'd have to multiply e to the x times e to the x. Just like I would have to multiply x times x to get x squared. Then I want to multiply to get 28, so that ends up being, oh, this is the one I told you guys to change, right?
Yeah, to plus.
Sorry, so this should be a -28. So if you didn't hear that and that was your question, sorry. That wasn't factorable the way it was. So it needs to be a -28. So this ends up being multiplied to -28, add to -3, so -7 plus 4. So I still need to solve this. I need to figure out what my x is. So I'm going to set each of these equal to 0. So I'm going to move that 7 over and find out e to the x needs to equal 7. I don't know how to solve something with e to the x, so this is where we switch it over to logarithms. So this is ln, and we're going to review logarithms more today as part of our homework. So if that's getting kind of rusty, hopefully they'll come back to you. Ln of 7 should equal my x, and you just put ln of 7 in your calculator. However, this other one, we talked about this very little, like when we talked about logarithms. You can't actually take the logarithm of a negative number. It's not possible. So when you go to solve this one, because essentially what they're saying here is e to some power is going to equal -4. That's never ever going to happen. There's no number you can come up with that e to that power will equal -4. So when you try to do ln of -4, you're going to get an undefined or domain error. Something on your calculator will freak out on you that says it's not okay, and that's not possible. So this one isn't a valid solution, whereas this one, bless you, is like a decimal. Okay? So something like that, I guarantee, will be on there. Hopefully it works out the right way the first time. So 24 through 20, or sorry, 19 through 24 are all our different laws, sines, and cosines. Now, with right triangles, what rules do we use? SOHCAHTOA. So these first three, you guys should have been able to solve these like back in geometry. Like you learned these in geometry. This is not something that you didn't know how to do coming into this class. Like this was something you knew how to do. So I'll do number 20. I think, oh no, wait. Yeah, 20 I think is a harder actually, now that I say that. I don't know. 19 or 20, which one to do? I guess I'll do 20. Solving for an angle though. Maybe I'll set this one up with you guys. Kind of try to. So on number 19, we have to find an angle. So we have this angle theta. And now if I know this angle, then I can find the other one. That's why 20, I guess, is a little bit easier in that way. So I'm going to find theta, and then I'd suggest you find the other one. But if this is our theta here, this is our opposite sine. This is our adjacent. And this is our hypotenuse. Now, if I want to find that, I can use any of the trig functions because they give me all three angles, or all three sides. So, I don't know, what's your favorite? Cosine. So cosine of theta is going to equal a over h. So we're going to do 9 over 15. Now in order to solve that, we have to use that inverse cosine. So you do inverse cosine of 9 over 15. And again, make sure you're in degree mode, because if your calculator does something kind of crazy, it probably means you're in radians. You will not need radians on the exam. You have to be able to convert between radians and degrees, but you don't need your calculator to be in radians to have that happen. Okay? So then you should get, for theta, you should get 53.1-ish. And then once you know that, you should be able to find the other angle. Okay?
So for cos, we find the inverse of cos?
Yeah. So it's that like cosine, it's the little button above the cosine.
Yeah.
That should give you that 53.1. Okay? Now in number 20, finding the angle is easy. Finding the other two sides is not. This is where we have to do a trig function in order to figure that out. Now, I would have chose to use the other angle. I think it makes it a little bit easier, but in case you didn't notice that, I'm going to go kind of the tougher of the two ways. Like this probably wouldn't have been the way I would have done it. It wasn't the way I did it, but so if I use this 54 degrees, this is my opposite, this is my adjacent, and then this is my hypotenuse. I love that you're eating chips off yourself. And then we actually said, I wonder if there's stuff in there, and there is when you're eating pregnant. Part of his costume. All right. So we have to use the opposite in this case. So I have to either use so or tangent, or sine or tangent. So it just depends which one you want to use. One's not easier than the other. So if I do sine of 54 equals opposite over hypotenuse. So I'll just call this h. Now this is tough when the variable's in the denominator. So what we have to do in this case, we have to cross multiply. And then I'll solve for h by dividing by the sine of 54. Now technically this problem is easier if you actually use the other angle, which is what I would have done, and then I would have done tangent. but I'm going to do h equals 2 over the sine of 54. This, again, this is something you guys knew how to do, so this is something I don't want you guys to get wrong on the exam. So if it means going back and practicing, or if you say I need some more practice of a certain kind, let me know. I always can find more things for you guys to practice. Or we have tons of reviews and things that you guys can go back and just look over again, like things that you guys have already done. And then once you know that side, you can either use trig again, or you can use Pythagorean theorem to find that other side, and then the other angle is just the fact that they add up to 180. All right. The next couple are law of sines. So then once we learned that if it's not a 90-degree triangle, we need the law of sines and cosines to help us. Now this one is law of sines, or both of these are law of sines. The way to know that is basically you try law of sines, and if it doesn't work, then use cosines. Or another way is cosine is always side, 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 or side angle side that you know. So if you look down here, cosine is the tougher of the two. So if you look, this is side angle side, and this one's side, side, side. That's how you know you're using law of cosines. So if you have a hard time determining which one you should be using, this is kind of a good clue. And this is the harder of the two formulas. And we'll come back to that one in a second. So we'll do law of sines here. Do you want one where you have to find the angle or the other side? Which angle's a little bit tougher. Should I do that?
Yeah.
Okay. All right. So I know 110 here. That's across from 30 degrees. So, and if you don't have law of sines down, it's the sine of the angle over the side that's across from it. And then I have to pick the side I know, so I'm going to use angle R, that's across from 13. Again, if you're getting a really weird answer, either you're doing something wrong or you're in radians. Yeah.
So you know how in this unit we had little a and big A?
Mm-hmm.
Which one is the angle big A or the angle?
Yeah, and the little a is the sides. Yep. Yeah, and they use that throughout. So little a is the side, big A is the angle. Same thing, little b, big B, little c, big C. So we're going to cross multiply here. So we have 30 sine of R. Sine of R equals 13 times the sine of 110. I'm running out of space. Must be 110 there. Clearly. All right, so then to get sine of R alone, I'm going to divide by 30. So I'm left with sine of R equals this 13 sine of 110 over 30. So this is going to be a crazy decimal. 13 times the sine of 110 over 30 is not going to be a nice number. I need to find R, so I have to do the inverse sine of that fraction. So to figure out what R is, I'm doing the inverse sine of this thing. Sorry, my board is really struggling today. And so making sure you guys can figure out how to get that into your calculator. This is something to be practicing, and making sure you can get to match. Again, trying to figure out, did you use radians? You should use degrees. And so R should be about 24 degrees when you're done. Once I know R, I can easily find Q. And then to find that other side, I have to do law of sines again. So you can use law of sines on everything in this problem. All right, then we go down to 23 and 24. Those of you guys who did that, do you have a preference on which one I do? 23 is harder, I think, but 24 you were.
Actually, I did that on both.
Okay, let's do 24 then.
But that one's easier. I don't know.
Oh, sorry, 23 I meant, sorry. Yeah, there's more places to make mistakes. I can always look with you, but.
I don't know what I did.
Oh, this needs to be multiplied together, because that's stuck together, so it's gonna be 776 minus that. You can actually put that exact thing in your calculator.
Oh, okay.
You guys, this side of the 24 over here, this one you can like put that exact like whole like right side of the equation in your calculator, and then just take the square root of it. It's really just, I mean, I would put it all as one, so it makes it a lot better.
What is?
On 24, when you enter all that, the whole right side of the equation, like let me steal Maddie's here for a second. Like, and she can put that whole thing in her calculator and then just take the square root of it. So, and she made mistakes because she was trying to slow down and do it, like chunking it out, but done. Okay, we'll do that. All right, so let's do 23. They want angle R. I did not make you to find all the angle or all the information in this one because this one would be a pain to find all of them because you have to do log cosines and log sines. So, if you guys remember, log cosines, they're really long formula. So we start with is the side across from the angle we're looking for. So that's going to be 28 squared. So that side is being squared. Then the other two sides, so equals the other two sides being squared. And again, this big formula you should have written down somewhere. Minus 2 times those two other sides again. And then cosine of angle R. Now again, this one's really easy to make mistakes. If you try to put the whole right side in your calculator, it'll be a big mess. So don't do that. This one you have to do little chunks. So I have to do 28 squared. And I'm going to do these two right now together. I can do 18 squared plus 12 squared. That's okay to do. Minus 2 times 18 times 12. Okay, this is typically where people go wrong. So they see these two and they just want to subtract them because that looks way nicer to subtract than leaving us kind of those crazy numbers. But this is being multiplied by a variable, so I can't take those apart. They're not like terms. So instead I'm going to move this 468 over. So 784 minus 468, we get 316 here. Now again, I'm trying to get R alone, so now I'm going to divide by that 432, the negative 432. So 316 divided by negative 432. And get some kind of crazy decimal, which seems to make 0 sense. So this is cosine of R. So I'll do the inverse cosine now of that crazy decimal. So I get 137 as my angle. So R ends up being 137 here. So you're doing inverse cosine on this step. Is that kind of coming back to a little bit if those like 6 questions were like your big questions? Is that feeling a little bit better? I know it's been a while since we've done that, or it felt like forever ago. Just need a little something something. Okay, let me